PhD Pre Submission seminar on designing of control area network based event data recorder and data analysis for evidence collection system under the guidance of Dr. Anand sir. This is the content of our presentation. I am going to design a event data recorder system. The event data recorder is nothing but actually a black box system that is using aviation system. In aeroplanes, whatever the black box is there. Similarly, I am going to design the system for a ground vehicle. That system is I am going to implement through a control area network. In order to get the standardization of the things, so I am making use of a control area network. The main motivation area behind the research is that, for example, if we see this figure, then we can observe that in order to get the analysis of the or to go to the exact reason behind the accident. One has to go to the physical witness present out there, one has to go to the skid marks, and one has to identify the degree of damage in order to get only one conclusion to get the exactly what is the cause behind the accident. So this, if we, for example, if we design a system that which is already present in a car, then this system will act as one of the witness, individual witness to the that particular accident. If we do so, then that witness can be proved in a court. But main reason is that event data recorder system vehicle involving design or implemented in a vehicle in India is very less. Whatever the vehicle we import from the outside, event data record is present in that vehicles. So still India is but little bit not aware about this event data recorder system. So already it is being implemented, but I am going to implement it through a control area network based system through which data fetching and data retrieval will be faster. Standardization is improved. All the serial communication takes place in a very efficient way. These are the applications where it can be used. It is used in crash investigation, evidence collection, driver monitoring. One can monitor the driver habits by remotely locating in one place. Insurance claiming, fraud insurance claims, license issuing system, and accident reconstruction. The main objective is to design and implement event data in CAN system. Working of a CAN study sensors, flash, and at the end we have to go to the exact analysis. What is the exact reason behind the accident? That can be done graphically as well as in a tabular form. There are lot of types of event data recorders. Event data recorders are generally only those recorders which only record the pre-crash data. Prior to the accident, just prior to the accident, 5 seconds or 20 seconds data is being fetched and it is being recorded. Some data recorder records during the crash and some records after the accident. Some also records record the data. For example, if one vehicle collides with one object, after that it collides with some other object. Means two events it is recording. These are the literature review. In the first paper, it deals with the title is survey paper on CAN-based technology in the vehicle. The advantages of the vehicle deals with only CAN-based technology, but no collection of data is being implemented here, and analysis part is missing here. After that, second is IEEE paper on monitoring driver habits through the automotive CAN network. Here, the onboard diagnosis module is being there. Engine temperature and only simulation and graph is plotted, but mainly they focus only on the lane changing mechanism of a car. Another paper it deals with the title as ARM-based event data recorder for automobiles. It only records the real-time data. It makes use of good processor, but the main drawback is that only monitoring habits only GSM and GPS based systems are only used, but not main recording is missing. From this literature review conclusion, I found that also this evidence collection system I am trying to implement. For example, all the data from that vehicle which meets with an accident, it is recorded. Only the authorized person is having any rights to go to that vehicle and fetch that data. No other, that is authorized person here is a police. That only can go, or insurance claiming person. That only can get the data. But here only insurance claiming and police should have only rights. But if one has to keep a track of one particular transport vehicle, then it is not easy. Actually, event data records are available in market. They cost in about 6 to 7 lakhs. They are only implemented in the vehicle, but to fetch a data from that vehicle, it requires a software that is also in lakhs. So, in order to design an efficient recording system as well as analysis part, that is the main aim of my system design. Data standardization issue is missing here. Data in the literature that I try to improve, I'm going to improve storing techniques, fetching techniques, and data analysis. Generally, event data recorders consist of sensors, processor blocks, storage, and retrieval systems. And number of sensors are going to be used. Processors, I am going to make use of a CAN controller. After that, it process, filter out the unwanted message, and going to the ARM-based system. And after that, storage mechanism is there. Generally, ARM-based system is interfaced with the memory card, or it can interface with the pen drive. That data has been fetched and recorded and retrieved to get the exact analysis. The CAN specification, it works on the physical layer, data link layer. It is also
standards may be there, na? ITP standards may be there.
Yes, CAN, yes sir. CAN standardization, yes sir. I am going.
You can just use that.
Yes sir. The CAN standard is there, CAN 2.0 and 2.A and 2.0B. The only difference is that it consists of only 11 bit of identifier in 2.0A and 19 bit of identifier. Means data storing mechanism, that data can be stored in a CAN frame in a good quantity. Only difference is that rest only start of the frame, identifier, end of the frame, acknowledgement. Here design methodology consists of event data recorder, evidence collection system, and data analysis. This is the overall block diagram of my system. Here the data analysis can be done. Here event data recorder only triggers. It consists of sensor. It consists of only sensor and hardware implementation. Evidence collection system, it consists of storing devices, and data analysis consists of representing that data in a graphical way, so that layman can understand what had happened to the vehicle just prior to the crash. This is a block diagram of evidence collection system. Initialize the sensor, store the data, fetch the data, and go for data analysis. And for fetching purpose, I am making use of a VB-based software. In that, I have implemented a binary tree, balance tree, and in which all the leaf nodes and there, so that the data can be arranged in a very proper way. Here the B-tree algorithm. For example, I have already said that if, for example, all the data is saved in a police database. Then, for example, if one person approaches to the police that I want that data of that particular date, of that particular time, then he put a query. Depending on that query, all the entries on that particular date and time, it will be fetched, and it will be only given to that particular person. Not all the data is being given. Such type of system is also designed. This is nothing but a system design in which in the event data recorder I make use of IR sensors, vibration sensor, brake sensor. IR sensor is used to detect the obstacle adjacent vehicle. Vibration sensor is to detect the jerk or the crash events that car faces, and the brake sensor is to monitor the driving habits. How many times the driver presses the brake? If, for example, if the driver observes some particular object and he applied brakes or not, means accident is intentional or not, that can be going to the conclusion.
Gyro sensor and vibration sensor. Need two different ones. What is the implementation?
Gyro sensor is different. Gyro sensor is used to implement the tilt angle. How many times the vehicle rotates after collision? How many times the vehicle 360 degree rotation? Vibration sensor is just used to take the jerk produced in that particular vehicle at the time of collision.
There is then also accelerometer is there, right?
Ha.
So any of these is
Ha.
same or?
No, accelerometer and vibration sensor is working on the same axis. Alcohol sensor is used to detect the whether the driver is consuming alcohol or not. Where in standard level, for example, 300 milligram per liter is the standard. Where it is approaching above that level or below that level. All these things are taken care of. Steering angle, we are taking a steering angle as in terms of 3 axis X, Y, Z, depending on that one formula is there, and it is going to calculate the sudden change in the steering angle, right or left. All this data it is being fetched and it is going to the CAN module, which consists of CAN control and NCP 2515. CAN message format is being used here. It is only because to fetch the data in a serially way. It also has the CAN as a feature of remote transmit request. That feature enables, for example, if one particular sensor triggers, for example, if a driver is drunk above certain level, then in that case, all the data from various sensors we need to catch and we need to store that data in a database. That remote transmission request feature is being used in a CAN. And also it filters it avoids the overheads of a ARM processor. ARM processor used here is LPC2148. After all the data is being saved in a ARM processor, it is then going to the recording system and further it is going to the analysis system and user interface system. This is the flowchart of event data recorder system. Start, initialize the sensor, collect the data from through the CAN. If the sensor exceeds, then store the data. Otherwise, information is recorded. And initially, again, it is going to the initializing sensor. If any of the sensor is not cross the threshold level. Evidence collection system flowchart. I already told that I fetch the data from memory card. Algorithm B2 algorithm is there. After that, fetching query based system is there. This all implementation is I have done event data recorder module in a 5 module and evidence collection system in 2 modules. After that, I am going to the data analysis. When I started this research work, I had not used any sensors. I made use of simple potentiometer, fan regulators type. This is my first module. In that, here I am making use of one motor, which is just this motor, and one shaft is white shaft is there. This is just working as a. I am going here only to calculate the speed of a vehicle. Whenever the shaft and crosses the LDR, depending on that number of rotations are calculated, heat speed is calculated. What is there? We used to measure only steering angle. Basic first initial level. I make use of these basic things. After that, here I am making use of a MAX 232 and RS 232 for serial communication, and I am going to the PIC microcontroller. PIC microcontroller is used in initial stages, and all the data is stored. I have also interfaced this system with the visual basic phase system, which is used to measure the eye blinking movement, also whether the driver is in stress, whether he is moving his pupils n number of times or not. All this data is being saved in a log file. This log file is having the nature of a date, time, speed is here, depending on only potentiometer, and this is not exactly a real time speed. Temperature sensor and the steering angle and the eye blinking movement. Depending on that, visual basic graph is also produced. Initial vibration shows that sometimes it requires to initialize the system. After that, it maintains the uniform temperature. Speed is also similarly this graph shows that vehicle speed throughout the journey. Steering movement, here I am making use of only pot, so no conclusion can be drawn from this system. Eye blinking movement at that particular 1532 and 1533 minute, this person has blinked his eyes. How many times is blinked? It can also be saving a database. Depending on that, this eye blinking and parameter based table is also produced. Also, I produced one alcoholic system in which only I make the use of a push buttons initially. Push buttons ensures that whenever the dash is between from another obstacle, crash is detected and it is stored in a database. And this is interfaced with the GSM module. Message is also coming at exactly the GPS locations and the vehicle speed is what. Depending on that, it is going to the remote. It can be tracked through a remote user. After that, I come to module 2. Here, I try to implement the sensors, lot of sensor, LM35 sensor, accelerometer sensor. Here, I have designed this system. After that, GSM module SD card is interfaced with the ARM processor here. LCD, all the whenever the event is triggering, it is showing the results on a LCD as well as it is showing the same in a SD card. Data is not in a sequential manner. That's why I have made use of Arduino kit to interface with the ARM system, so that the data is saved in a sequential manner. Data is stored in a log file as well as in a message is saved also to the remote user. In the module 3 implementation, I make use of the ARM7 LPC 2148. Here a equal sensor is, and the speed, position, proximity sensor, temperature is an interface. Here I have set the extreme conditions at engine. For example, the vehicle engine temperature crosses 100 degree, then it will fetch all the data from the different sensor and store in a database. Alcohol sensor limit is also here defined as 24 milligram, but in India it is 300 milligram per liter. Initially level I have taken it as a 25 milligram per liter. After that, obstacle sensor, whether the adjacent vehicle is near to that particular vehicle, if it is less than 1 feet, and all the data is saved. This is actual implementation. Alcohol sensor. There is one conversion formula in order to detect the sensor output in terms of milligram per liter. This is that conversion formula. Whatever the output is in milligram per liter, we have to calculate. Then analog voltage of a sensor in millivolt multiplied by 0.002. It will give us the exactly milligram per liter reading of a particular alcohol sensor. This is also been shown in a LCD. Similar temperature sensor is also shown. Temperature reading. If it is crossing exceed limit, all the data from various sensors is also recorded. This is the table showing module 3 implementation. Alcohol sensor readings are detected, threshold value set. After that, module 4, here I make use of GSM based transmitter and receiving system. It is implemented through a CAN module NPC 2515. Here this is act as one transmitter, this is act as one receiver. This receiver is connected to a VB based system. All the data from the various sensors is being fetched, and it is remotely it is being sent to the GSM module. The number of the GSM module, it can be changed depending on SIM card you are insertion. That number can also be changed through this keypad. Means, for example, it is not fixed. It is not hard coded. One can change the number also depending on that, and it is interfaced with the VB based system, receiving system. This is actual implementation, and this is VB based software is being web page being designed here in VB. It is showing the GPS coordinates, accelerometer, steering angle, whether the seat belt is on or not, where or not, and airbag deployment is in feature scope. I have not exactly done the airbag deployment. These are all the changes. This is steering angle XY, XY, depending on that XY, and steering angle can be calculated. In module 4 implementation, I am making use of this various sensor interface with the CAN, and this is the flowchart of our system. This is the actual implementation of the module 5. Here all the sensors it is consists of EC2515 max serial communication port. All the data is through the CAN system. It interface with the ARM system, and it is going through the pen drive, and all the steering angle, shock sensors, gyro sensors, temperature sensor, alcohol sensor, IR sensor is also implemented in this module. This is CAN based implementation. This is data is not in a serial way. So I need to make the data in a serial way. So I make use of VB based software and fetch the data from the log file .txt file and convert it into a human readable form. These are the threshold condition set and detected. In module 6, it starts with the evidence collection system. In the evidence collection system, I make use of one software which is try to fetch that Excel file. From that Excel file should be of a standard format. First column should be one particular sensor, second column should be temperature sensor. In that way, all the data is being fetched and it is given to the evidence collection system. The data is fetched, and for example, if some particular person asks for a data on that particular day and time, if that query is failed, then it should pop up as a data is not found in the database. If that data is found, then all the data from that particular date and from that particular time, 20 readings are taken out, so that only that particular data is being given to the insurance claiming system or that particular person. This is the graphical representation of engine temperature versus time, adjacent vehicle with respect to time, speed versus time, brake pressure versus time, and all this data is combined in a graphical way in order to get analyzed that accident happens because of these parameters in combined way. For example, you can see that the obstacle is detected as well as the brake is suddenly brake is being suddenly pressed. Because of this, we can say that the accident happens because of this particular reason. This is a combined graph showing the analysis. This is a driver behavior model. This is also accident details. Accident happens, for example, due to the impact. Then at that during the when that impact occurs, what is the status of other sensors? After that, I would make use of one module in which all the data it is being fetched in a runtime. It is being fetched in a MATLAB, and graphical analysis. It will show that the temperature sensor, humidity, XYZ, and the XY axis and the speed. In a obstacle is detected. It is also shown here. GPS location, accelerometer sensors. All these readings are fetched and showing in a one graphical representation. I have considered 4 cases. I have put my hardware in one particular car, and I have called Uber cab, and I asked the driver to go from one particular location to another particular location. I only travel for 15 minutes, 10 to 15 minutes. I consider that 4 cases. Depending on the 4 cases, that Excel sheet is produced, and it will show the analysis part that the accident happens because of the alcohol consumption of the driver. For example, you can see that here the alcohol consumption is alcohol consumption. Here the alcohol consumption is being done by the driver. By stopping the vehicle, he has drunk the alcohol. After that, he has again started his vehicle and again concluded, and after that he has met with an accident. So all these such different 4 cases are being produced depending on the alcohol, steering angle, temperature, and the speed. Finally, I conclude that this system can be reduce the it can improve the driver performance. Insurance claiming, it can use as an insurance claiming system. Can be system is implemented so it is efficient to fetch the data. Future scope is to record the video. If I possible to record the video in that particular event data recorder, then it will be more beneficial. These are my references. The list of publications. 3 journals are there and one publication in Spring Journals Conference.
So, see, for also data analysis systems, one important thing which is called as anomalous events. Okay, so see what happens is that there will be so much amount of routine data which is generated, whereas when an event takes place, for that we wish to collect data, we wish to collect more data which is relevant and there. You know? So there must be some way by which we can identify what we call as anomalous events, which are attracting my attention.
Yes, sir.
So and that anomalous event detection. So there is, how do you know an event is anomalous? So we have to go through the data which is being produced, and then through that one may be able to identify and say that okay, this is normal, but this is anomalous.
Sir,
So do you have anything for that?
yes, sir. When I implemented this system, only when my temperature exceeds about 2 degrees Celsius, then only it will show the fluctuation in this graph. And in this way, I am making use of data compression technique is also here.
Correct. But one particular anomalous event must be then correlated with another anomalous event. Okay, that will then indicate that something drastically has gone wrong. Okay, so you have to have some way in which the two sensor timelines can be aligned and correlated. Okay, that's also very important for doing this kind of analysis.
Multiple parameters.
Yeah. So one scale of one parameter is going, another one is also there. But what is the unless the clocks has to get aligned, rarely clocks will align. There will be some clocks usually. So then what happens is that we need to have some way by which some temporal alignment will take place. So or if there is a synchronism mechanism or self-clocking or some kind of things there, then that way we can do it. Yeah, so anomalous event detection, I think so that will be, if you are able to do that, that is going to be quite a good one. Other important thing is that since your project is a practical one, you should concentrate on the overall package design. So the overall package should be compact. It should be, heat resistant. It should be impact resistant, and all those kind of things are required. No? Then it will be a really practical design.
Product design towards it.
Yeah. You have to think of that as a complete, not just put it on board. You have to think because it has to have environmental protection, dust protection, heat protection. Those kind of things will be there. And other thing is that calibrations. So calibrations are very important. Otherwise, all your data produced is meaningless. So there should be ways for detection of the calibration, detection of whether it is going out of calibration and things like that. So some automated approach should be there by which your sensor data is getting validated and seeing that it is producing proper data or not. There are some solutions.